A very warm welcome to all of you to the session, which is about research and graduate studies in the US organized by SARSTEM. The guest speaker for this session is Mr. Jay Shah. I'll let you know about him in brief. Jay is a computer scientist and a first-year Ph.D. student at Arizona State University, co-advised by Dr. Baoxin Li and Dr. Teresa Wu on joint projects of ASU-Mayo Imaging Informatics Center. Currently, his research projects focus on developing deep learning models for biomarker discovery for Alzheimer's disease using multi-modal data and building interpretable AI models for healthcare applications. These applications are joint collaborations with Mayo Clinic, Barrow Neurological Institute, and Banner Alzheimer's Institute. To all of the people who are present in the meeting today, I'd just like to request that we'll have a question session at the end of the meeting to avoid a bit of interruption. Jay will first talk about his journey and his experience and about his current research and everything that he has gone through while he's building up his career. So without further ado, I now request Jay to take over. Jay, to you.
Thanks a lot, Akshat. Thanks a lot for the wonderful introduction. Let me just share my screen. Just a second, I'm trying to learn what's... All right, can you guys see the slides?
Yeah. Yes, it is.
All right. Oh, okay. So everyone, I'm Jay Shah. I'm a PhD student at Arizona State University, and as Akshat mentioned, I'm working on a few deep learning projects as a part of my PhD thesis that I'll be quickly talking over in the next few minutes. So prior about me, before I joined over here as a PhD student, is I started my undergrads in Information and Communication Technology at the Dhirubhai Ambani Institute of Information and Communication Technology in 2014, and this college is situated in Gandhinagar in Gujarat. And after I joined over there in my undergrad degree, in 2017 I did my first abroad internship at NTU Singapore, which is a very big research university, where I attended that in the summer of 2017 as a visiting research assistant. And over there, my project was on 3D point cloud compression and decompression management, and it was an academic grant that was that the professor of mine was working on. And the goal over here was to work on a video input format that can be compressed and decompressed in a real-time format. And as some might know, this algorithm was later on developed for the MJPEG format that we normally used. So my professor is one of the chair members for the open source format for MJPEG, and my job over there was to learn more about how we can do this very efficiently. And so this was my first introduction to, in general, research in the domain of machine learning, where I started learning more about how exactly we can do research. When we say research, what does it entail for a student in general? So I learned about how to do literature surveys, how to work on implementations, because we pretty much never find these implementations online. So this was my first hands-on experience abroad from India that I learned. And I'll be happy to talk more about these experiences later on if somebody wants to learn more. After that internship, I realized that I was really interested into machine learning, and so a year later I joined Hackerrank. I'm not sure if most of the people over here are aware of Hackerrank, but it's a tech recruitment firm where they interview business to business models. So they have business to business clients, and candidates are the ones that they are interviewing, and they provide a platform for people to basically apply to different companies. And I joined over there as a machine learning intern. So my job over there was to use data analytics as a part of the platform's data and learn more about how we can exactly use that to understand the needs of clients better. And so this was the goal over for me, and this was my first experience learning more about applying machine learning in real world data, which was pretty much different than what I was doing in a part of my experience at, say, NTU or with professors at my undergrad college. And this was the point I really decided machine learning was something I still lack a lot of knowledge. I do think that I have the basics. I was learning a lot of courses, but I still felt that I'm not really up for it. I'm not really have the whole expertise knowledge. And hence, after I graduated in 2018 from BIST, I decided to pursue masters, because I think masters was the only way that I could learn these intersection of basic conceptual knowledge versus where I can actually use. So I graduated from DIST in 2018, and then I moved to US for my masters. And I came to Arizona State University for choosing my master's in computer science in 2018, strictly after my undergrad passing. And over here, when I came over here, my first opportunity that I got to work with was in 2018 itself, in my first semester, that I worked with Professor Frank Wilczek, who is a Nobel Prize winner in the physics category. And his work was on time crystals. So he was pretty much uninterested into how learning these time crystals work, which he invented himself. And he was interested in a very novel side topic, which was machine learning. So even he found out that machine learning was something really, really interesting if we can work with data. And he was obsessed with old art paintings. So there are, like, ASU has a great structure of museum of old paintings, Picasso, I think Michelangelo, and a lot of other people structures even from them. And his job was to, regardless of it's a painting or a sculpture, he would like to know what is the what is the age of these particular sculptures and architectures. And he was curious if we can use actually these machine learning technologies or machine learning tools in general, which are using computer vision technologies who can process lots of data and still provide some great very insights. So he was interested in this very side project, and I joined his lab because of this particular reason. And at the end, we actually built a very nice prototype of a camera-based system, which was a hyperspectral camera, which is unlike it has 1,000 channels, like what we have in our iPhones is in 3 channels, red, green, and blue. But the camera that we used had around I think 1,100 channels. And what we were doing is we were collecting all these informations and trying to learn what is the age of painting. Some of these sculptures were around 200 years old. Some of them were fake. And the ultimate pitch that I think we made in 2019 was to go to a venture capitalist and show this particular product. And what it will do is it will tell you immediately in few seconds that the painting that you are presenting to the camera is, let's say, fake or not. And so this was a very cool project, not a very researchy project, but it was my first hands-on application. And of course, working with a Nobel Prize winner, that was really cool for me. And after that, because I was interested into imaging and computer vision in general, in 2019 I got my first internship as a research and development intern at Philips Research Labs in Cambridge over here in Massachusetts. And this was the first time that I was interested into medical imaging. And I didn't knew I knew medical in the domain of medicine they are using AI for helping people solve diseases, but I wasn't sure how exactly this was being done. But I always found this to be interesting because these are two core sciences, which is medical science and computer science, and the application was something not a lot of people knew about over here. And so when I interned over here, Philips is the biggest hospital equipment supplier in the North America domain and also in Europe. And what I learned from there was while I was working with these amazing people, research scientists, is the way they are incorporating these knowledges is much more real time based. Like a lot of tools, the way they are using AI is not what we see in academia. In academia, we see slow yet innovative, but very slow applications. Like the model is training over, let's say, a few days or few weeks, and some things that we see. But when I went over there, when I saw the models that Philips was learning was instantaneous. Like they were running in few seconds using some very good optimization tools, some good hardwares, and a lot of stuff. And so what I worked over there was a contactless patient monitoring system. So in ICUs, you do not have access to the physical touch to a patient. So they have developed a kind of a specific camera in itself, and also the compression formats that they were using in order to get these video inputs. And using only a camera which is situated a few feet away from you, you can actually monitor your heart rate and your pulse rate. So how much fast you are breathing versus what your heart is pumping up. They can actually learn that from a very uncompressed video and frame rate system. So this was pretty cool for me because we used a lot of deep learning techniques to do that, and this was done every second. Like even a half a second delay was something very critical for these people. So this is something I learned, and this was the point I realized medical imaging is something I want to be at. And so after completing that internship and also graduating from my master's degree in 2020 from Arizona State University, I decided I want to do a PhD because, again, this is something I need to have an expertise rather than just having a breadth of knowledge. I was exploring a lot of stuff, but I didn't have any expertise where people can say that I can work on this problem end to end. So this is the point that I realized that I really want to do a PhD. And I, because of my Philips internship and my whole expertise in computer vision domain, I chose my thesis topic and my advisors to be who's working in the healthcare domain, because I didn't want to be working on some, let's say, robots or ad generation or network algorithms, but something that I was really curious and interested was the application of AI into healthcare domains. So this is when I think I joined Arizona State University again as a PhD student now. And and right now that I'm collaborating with is this is my I think I'm just on the verge of completing my first year as a PhD student, and my projects over here. So Mayo Clinic is the biggest chain of hospitals in United States, which is a non-profit organization where doctors and a lot of other collaborators work on these projects. They write grants and a lot of things solely based on a non-profit architecture. And so my projects are on the cross collaborations between Arizona State University, Mayo Clinic, and also a place called Banner Health, who's working on Alzheimer's disease, which is the biggest group in the whole world who's working on Alzheimer's disease in general as of 2021. And the three projects that I'm particularly interested, and I'll be happy to later on explain if somebody would like to learn more, but I'll just make it brief over here because I don't want to get into too much of the weeds of details. Is the first project that I'm mostly interested in is the post-traumatic headache. So all these two diseases that I have listed over here are neurodegenerative diseases, which means the significance why AI is so much needed in these topics is these are irreversible diseases. Once you're detected with these diseases, you cannot go back being healthy. So that is the problem right now the medical professionals are facing. Once you're detected with, let's say, post-traumatic headache, there is nothing much I can do to reverse you physically that can make you healthy. All I can do is just provide you medication so that you are not suffering from the disease. Same with Alzheimer's. It's a dead end. You cannot go back. But there has been sufficient literature in the medical science that says if we can predict these diseases early, few years early, we can actually take back the symptoms and we can early intervene these patients and try to learn more about what's happening, and we can actually save them from any kind of potential disasters. So this is where AI comes in. So this is the brief overview. We are trying to predict if a person would have Alzheimer's or post-traumatic headache few years ahead before even the person knows that he's suffering from it. Because
Jay,
the symptoms could be
sorry to interrupt. Have you moved on to the other slide because we can only see the first slide? All right.
oh, so which slide were you guys seeing?
The first slide.
Oh, wow. Which slide do you see now?
Ph.D. in CS.
Oh, that's too bad. I'm not sure what's going on over here.
We can see it now. Yeah, it's fine now.
Can you see the About Me slide now?
Yeah, we can.
Okay. Okay, then I'll just quickly take a few seconds to show whatever happened so that it's on the picture. So I joined in 2014 in DICT, followed which I did my internship at Singapore in NTU in 2017, where I worked on the projects that I didn't mention. Then I joined Hackerrank in 2018, and then graduated from DICT in general in 2018. Then I did my master's, joined Professor Frank Wilczek's group over here, where I worked on the authentication systems, and Philips, as I mentioned, for my internship on patient-less monitoring in ICUs. That's all I discussed. Sorry, I didn't knew the slides weren't visible. Okay. So yeah, as I was explaining, so there are these three projects that I'm currently involved with, which are the neurodegenerative diseases, and the beauty about these projects, apart from the medical significance, is when we see how AI can play a role, is the idea of multi-modal deep learning. So I'm not sure if anyone over here has explored the multimodal approach of using AI, but the beauty and the interest of community from AI research is how we can incorporate multiple informations of data into predicting a single variable. So we have data like neuroimaging data, MRI data. We have clinical data where we have questionnaire data. So they have questionnaires data within the whole cohort of the data that they have collected. They ask questions like, what is the scale of intensity of headaches you are getting, and what is your background, what is your demographics, and a lot of other stuff. And the clinical data where they have gender information, which is specific to the physical attributes of a person. And we are trying to incorporate all of these data into one modal approach, which is using AI to combine them first of all, and then using a combination of these predictions to predict the ultimate response variable. So this is something very new, I think. Based on my research and the literature survey that I have done, not a lot of people in the research have actually worked on this domain. And specific to post-traumatic headache, there are not a lot of people. The other project that I'm collaborating towards is the Alzheimer's disease, which is one of the longest standing disease that most of the countries face, not specific to any location. I'm collaborating with the director of computational lab at the Banners Health Association over here, where we are trying to first of all build missing modalities of data. So which is we have later on I'll share the abstracts and the papers that we have published very recently, just a few weeks back, was a technique called deep residual inception encoder decoder architecture. So using deep learning, we can actually synthesize artificial images of a person's MRI or PET scans. So PET scans are very costly over here. It takes around 5 hours, and we have to actually inject few chemicals into the brain of a person for which who is to be analyzed or diagnosed. And it's very painful for the patient who is going through. So he has to be given some sedative so that he doesn't feel it. But it's really costly. It's really harmful. It's really paining for the patient, and it's long. So using these deep learning techniques, we have created these synthetic artificial images so that the patient wouldn't have to go through all these problems in general. And that is the idea of using deep learning for something meaningful. And the results are really, really good. So we published in it's a conference. It's called Alzheimer's Association, which is the biggest conference for Alzheimer's domain. And I'll be presenting few works in this summer, I think later on in the next month or so. And this is one of the biggest projects that I personally am really enthusiastic about. And for the Alzheimer's disease, I also have a separate standalone project where the goals are different, but I'm still targeting the same problem, which is early detection of these diseases. I'm collaborating with a person called 𝘎𝑐𝐻, who is an expert of his kind for while he is working at Mayo Clinic. But his goal is to underline what are the biomarkers that we can actually see, which comes onto the exploration part of Alzheimer's. Like doctors know there are certain things to look for when the person is to be diagnosed with Alzheimer's. But what do we really mean by that? So we are trying to explore what's going on. What are the kind of biomarkers that we can actually see? So it's much more open-ended project. We don't have any publications there, but we are exploring. We are exploring a lot of biomarkers and all those things. And a later part of my PhD thesis is focused on, I think, as Akshat mentioned, was interpretable AI models. So I'm much more focused when we see these deep learning models being deployed in the real world and doctors are using them. The problem that happens is the doctor needs to trust these models. And these trust factors are a big reason that they are not using versus they are using. So that is the goal for me by the end of my PhD. I'm planning to incorporate some kind of methodology or techniques that I can develop alongside developing these deep learning models so that they are much more interpretable, they are much more trustworthy, or they are much more reliable. And the predictions are not just a random shot into the dark, and they are not called quote unquote black box models. So my abstract over here, I have few of the tools, few of the techniques that I have been using is based on game theory. I'll be happy to talk to any one of you later on if the question this pops up is how exactly we're using this old concept. This Shapley values come from 1950s or 1960s, and we are trying to make a shot at interpreting deep learning models. And our abstract was submitted to this annual meeting, which is one of the biggest meetings in industrial and science engineering. I think I forgot the full form for that, but this is something I'll be presenting in the next couple of months. And as I said over here, this other accepted abstract from the Alzheimer's Association is planning to be published in July, I think. So I'll later on share with anyone who would be interested. But I did talk a lot about I think technical stuff. So apart from what I do that that is not associated to my PhD or research is I host an ML podcast. And the goal for me is to what Akshat and other team members over here are doing is trying to help young students learn more about machine learning. And the reason for that is even back in my undergrad, when I was trying to learn more about machine learning, I couldn't find resources. I couldn't find the perfect set of people who I can talk to and who can share these insights. So what I did was over the time, I created these podcasts when I came over here for my master's. And the goal for me was to invite these people, talk more about how they got started. What was the inception point for them into AI? How did they figure these things out? And how exactly did they take any course? Did they took any master's degree? Did they do any kind of workshops like this or any kind of boot camps? what was the point that really worked for them and what was the pitfalls. So what things they wouldn't say that, okay, don't try this because this is not helpful. And over the time, I have gradually increased these podcasts to, I have invited professors, I have invited news reporters. One of the guys was a big author from New York Times over here. I have invited people who have won Forbes 30 under 30 list multiple times. I've invited people from Google, Microsoft, Facebook to learn more about a diverse idea of how they got started versus what they're working on. So most of the people, I ask them about their journey, but then I also ask them, how does machine learning look at Facebook? How exactly they are using these textbook algorithms and versus what students should know. So how should I prepare for cracking an interview of machine learning or any kind of data science role in general at these companies? So this is something I do out of my schedule for my PhD. And I'll share a link for all the people who would be interested into it. But you guys can find this podcast on YouTube. They are mostly video podcasts on available on YouTube. And these podcasts, I convert them for a podcast consumption on podcast platforms. So you can also find these podcasts on Google, Apple, Spotify, or any other kind of podcasting platforms. I contribute to IEEE as a kind of a volunteer duty that I have been doing since the past 6 years. So I'm one of the members that is under the category of impact creators, where we come up with these latest tools. So you might be reading few articles from IEEE as newsletters, or maybe let's say some kind of magazines where they list out what's the biggest happenings in the domain. And normally I'm a part of a group where I work with some very senior people, trying to learn more about what are the emerging tools for the next 5 years in terms of technology. And I was featured over there because I was one of the most young members to be contributing towards an impact creator program. So this is something I'm really passionate about, contributing to IEEE and helping other non-profit people who would be interested into these things. I often collaborate with an AI club over here, which is at the Arizona State University, which has a similar goal of educating people. We take up workshops like intro to Python workshops, how to build a basic convolution neural network, how to build a basic reinforcement learning model, what does reinforcement learning mean in general, and what are the jargons that people use. Like there are a lot of things like ethics in AI, concerns in AI. What do these actually mean? And we host very student-friendly sessions for people who might not know to learn more about them. And I think I won't be taking a lot of time over here because I don't have the whole flow to myself. But you guys can check out my profile over here, and there are a lot of things that I didn't mention because I think it's out of the scope for the meeting. But I have listed, like in the past, I have done a lot of open source projects that I have listed out on my website over here. You can go and check, and if you have any questions, let me know if you would like to have some kind of code available for that, and I can just share it with you for you guys to learn. But I have listed them on my website. There is a lot of other stuff that I have listed that I have done in the past, apart from my profile building as a PhD student or in general any kind of CS researcher. Apart from that, I think you can contact me if needed with any kind of doubts or questions that you have through LinkedIn and Twitter. I'm fairly active on these two platforms for this kind of questions in general. So let me know. Let me know if you guys have any question in general. And yeah, I thank Akshat and the whole team for helping me have this audience for me. Yeah, I'm done with the presentation. I'm done speaking. Let me know if you guys have any questions specific to research, doing masters, or whatever it may be. Thank you.
Hi Jay, great presentation. I actually had a question like which is sort of related to beginners. Like as a beginner, basically, you said your first abroad internship was at NTU, right? So what would you say from your profile helped you get that internship? What factors played like a good role in it?
I think having good recommendations from people and having some projects that you have on your profile where you took authority of a research project from its start really helps. So before I joined the first internship at NTU, I worked with a professor in my first year of summer, that is in 2015, I think. And I worked with a professor at my undergrad college on an author obfuscation project, which is one of the biggest problems in NLP, which is natural language processing. And over there I worked on, even though the contribution over there for me wasn't very significant because this was my first year of undergrad, but what I did by that internship was I tried to take up an authority of at least a very small task of literature survey, or at least building the basic implementation model of text loading. And so what helped was I had a recommendation from this particular professor who really helped me getting into touch with the professor at NTU. And because that recommendation really helps professor to professor, he would have more trust into understanding what he's really up for. Like, is the student just doing some kind of random stuff versus if he's actually interested into research. So I think, having a portfolio of at least 2 or 3 projects that is not on the internet, because having projects from the internet is very easy nowadays. So I think having those kind of unique projects that you can really speak more about really helps.
Thank you.
Mhm.
Also, could you elaborate a little on, I think you're talking about the black box, right? In one of your projects. So basically, the gaining the trust of doctors, right? So, like, could you elaborate a little more on that? Like, why don't the doctors trust it? Maybe because they don't understand the process, or is it something else?
Yes. You what you mentioned is one of the points, because even from AI research perspective, let's say if I'm using a deep learning model, I do not know what are the factors that I consider. So if, let's say, you are a doctor, and if I ask you why did you classify the person to be risky? If you classify a person that, okay, this person will have Alzheimer's, I can ask you and you can explain it to me in human language that, okay, because of symptom number 1, 2, and 3, which is in the medical history that we know, if you have symptom 1, 2, and 3, the patient should be called. But with deep learning, that doesn't happen. The accuracies are good. Like, the accuracy for deep learning models on cancer or tumor analysis is much better than humans, but it can just fail on very simple and stupid tasks. So I think that is the reason the doctors are not trusting, because with people we can test that, okay, if the person is intelligent enough to make these decisions, but how do we know for deep learning models? And the second problem that arises is with the data that we have. So doctors are learned the way doctors learn is through a process of whole their medical journey, right? Like 4 or 5 years of study, and they learn a lot of latent variables about these human body and the anatomy. Versus when we throw data at deep learning model, we are just giving them a very limited piece of information, which is just, let's say, MRI scans or clinical information, which is not enough for anyone to understand what's going on. So I think these small factors, like having just a very limited amount of data and having high accuracies, is just not a very trustworthy approach for the doctors to say, if I would be deploying these models in real world. Because, let's say, there are these whole terms of false positives and false negatives, right? So we wouldn't want someone to have any kind of false positives in these domains, because, let's say, for chemotherapy, if the model says that, okay, this person is going to suffer from cancer, let's proceed with chemotherapy. Chemotherapy is a very painful process. If these models are wrong enough, then I wouldn't want a healthy person to go through a chemotherapy. So the risk factors are really high. That's why there is a lot of scrutiny. We wouldn't care if the Netflix recommendations are bad, because that doesn't affect our lives. But over here, when we are dealing with real people and some real high stake money, high stake health conditions, and high stake life and death situations, the models need to have some good evaluation systems that they can trust. And apart from, even apart from healthcare, there is a whole different domain that works on transparency, explainability of AI models, interpretability of AI models in very sensitive scenarios. So yes.
Thank you.
Mhm.
Hi Jay, I want to know if do gap years affect your scope of graduation in abroad universities?
Um, I don't think so they affect, but it would be great if you can provide them with a detail of what did you do for those gap years. If you have something sufficient for an industrial experience or some kind of person who can say uh, what he or she did in those gap years is really meaningful, because having I have seen few people who have 1 year as a gap year, but if on the other hand they say that they worked on some kind of independent project or something that you can make up to make them realize that you weren't just idle sitting, I think that would be great. I wouldn't recommend having just saying that okay, I just had one gap year. Just come up with something as a proxy to say that what did I do in that 1 year. But I think no, it doesn't really affect you a lot by a major standard.
Okay, thank you very much.
Jay?
Um, I'm hearing a lot of noise. Can you repeat that?
Jay, am I audible now clearly?
Yeah, yeah.
Jay, Priyanka is here with us and she asked a question in the chat box. Could you give us some guidance about SOP?
Yeah. For I think the question is in regards to the masters or PhD admission. Um, I think SOP takes a lot amount of time, but what they really need to see is what really drives you. So most of the people that I've seen, they would try to come up with story of why they got interested into AI, how they took forward that interest, and what do they see in the future. So there would be at least 3 to 4 steps, and I think you can find this on a lot of online resources. Is first of all, you should talk about what really drives you to be a computer science student in general, or computer engineering, or whatever discipline you are. Secondly is how did you use your undergraduate experience to take forward that interest. Secondly, thirdly, what do you see yourself accomplishing in the next few years, regardless of what you are. So let's say for me, like I said, I want to solve these diseases regardless of whatever format I'm doing. And the fourth point that we make is why masters will help you accomplish the goal that you just said in point number three. So I think this 4 step process that I at least personally used while SOP really proved to be useful, and even for my PhD admission. So I think if you follow these 4 loop, and you can expand as much as you want, so you can make any of these points much more brief or concise as you might see. But having this architecture of these 4 points really helped for SOPs. Does that answer the question?
Yeah, I have a question. When you're a master's student, how important is it to have a published paper to get into a good PhD program?
So if you want to enroll for a thesis program, then I think having at least 1 or 2 papers into good universities is really important. So it's definitely not a one-way prediction process. So it balances out really on a global scale. So if you have low grades and your university is not well recognized over here in United States, then what happens is even if you have papers, they won't really consider that, because having papers is not the key. Like over here, you have to have papers that they think is really nice, so into nice venues. So just having papers doesn't really help, but if you have at least 1 or 2 papers into named conferences, which is highly revered in the research community, then that really helps. But it is not the only thing. I mean, getting into masters has no requirement for papers. If you're getting into PhD in general directly from your undergrad, then that's in that case you might require papers. But for masters, I think having good grades really helps. So focus on your grades and your entrance examinations like GRE and TOEFL. They are I think one of the biggest pivotal decision makers.
Yeah, okay, thank you.
Jay, Where would you be sharing the links, like you had told about AI Club and your podcast? I was quite interested in those.
Should I share these in the? I was planning to share with you over the email. Do you want me to share in the chat over here?
Um, you could share it on the chat as well. Like,
Okay. Let me. I think I'll just share the homepage of mine because every other link is on my homepage. So I think that would be the best way. For the yeah, on the first page of my homepage, I have every other link that could be useful.
thank you.
Is there anyone else among us who wants to ask a question to Jay? Okay. So if there's no one to ask a question, I'd like to thank you, Jay, for your lovely presentation and such experiences. We had a lot to learn actually, and it'll really help people to boost up their profiles for if they're applying for masters or they're applying for PhD in the US or any other country apart from India. So I'd like to end this meeting by saying thanks a lot for giving us your precious time. And to all of you present here, I hope that this session has boosted your thinking about going abroad for masters and PhD. So once again, thanks a lot, Jay, and it was really nice talking to you.
Yeah, thanks a lot, Akshay. Nice being here, and yeah, let me know if anything else I can do. But happy to be here.
Sure. Thank you so much.